This is Algebra 1, Lesson 39C, Advanced Ratio Problems. We're going to do examples 39.3 and 39.4. Example 39.3. The ratio of red marbles to blue marbles is 5 to 7. If there are 156 marbles in the bag, how many marbles are red? All right. Based on a previous lesson where we worked with ratios, we know that we can say the ratio of red marbles to blue marbles is equal to 5 to 7. For every 7 blues, there's going to be 5 reds. So that would mean if you had 14 blues, you could expect you'd have 10 reds, right? Because if you doubled the blues, you would double the reds. And that ratio would hold the same throughout the bag of marbles. But what is different about this problem is they now tell me there are 156 marbles in the bag. Well, that's not reds or blues. That's the reds and the blues. This is a total. Now, we haven't done ratio problems like that in this book, but if you took Saxon 8.7, you've probably, I'm sure, encountered this before. And I like the way the 8.7 book organizes this information, so I'm going to write it that way. I'm going to erase it, what I wrote, as we were thinking through it, and I'm going to set it up more like they do in the Saxon 8.7 book because I think it makes it very visual and it just makes more sense to me. So we're going to make a little chart. We're going to have reds, blues, and total. And then we're going to have the ratio that they give us and then what the real life number is. And you can draw in some lines if you want to. I'm just organizing the information. Now, they've already told me the ratio of reds to blues is 5 to 7. They also told me there is a total of 156 marbles in the bag. So that's my real. It's not real reds or real blues. It's real reds and blues. So it's 156 goes here. So what am I going to do? What else can I fill in? Well, if you notice with the ratio, I know that there are 5 reds for every 7 blues. So that would mean that 5 out of every 12 marbles, I'm going to have reds, right? Because I can add these two and get the total of the ratio. So I can put a 12 here and say that 7/12 of the marbles are blue. 5/12 of the marbles are red. Now, I need some information. What do I need here? It says how many marbles are red. So what they're really wanting is this number here. They're not even asking us for this number. So I really don't even need to know this right now. I could set up a new ratio and say that 5 out of every 12 marbles are red. And then I can use that to say, well, then that means how many of the marbles are red out of 156. And those have to be the same ratio. So when we have two ratios that are equal, we have a proportion, and that means we can cross multiply them. So 5 times 156 has to be equal to, 12R. When I multiply the 5 times the 156, I get 780, and that's equal to 12R. Now I see that I need to divide both sides by 12 to get the R by itself. And when I do 780 divided by 12, I get 65. So now, what is 65? Well, I can go back into my chart and I can see that I used the letter R to represent the number of real reds in the bag. And that would be 65 reds. And that would be your answer to this problem. So you can see you can use a little chart like this to organize your information and to be able to see your ratio. Your ratio is just going to be, after you strike out what you don't need, you're going to use what you have with what you need to make a ratio. So we had 5 over 12 and R over 156. Let's do that again with another problem. 39.4. The ratio of fish to crabs. So I'm already thinking about my chart. Fish, crabs. And you don't overthink it. You can abbreviate some things if you need to here, but I think it's important to organize it. Was 13-4. So fish to crabs, keep it in the same order. Fish 13, crabs 4. Okay? Now we also have a total that we're probably going to need. And we're going to have, these are our ratios, and these are going to be the real amounts in the real situation. And I'll just draw some lines to kind of organize that a little bit. If there were 119 fish and crabs, okay, so that's a total in the sea cave, how many were fish? So they're asking us how many were fish. So I'm going to call that F. Okay, so I need this information because I need to find F. I don't have this and I don't have this. Can I figure one of those out? Well, I can figure the total ratio. 13 plus 4 would be 17. So I can see that 13 out of every 17 are going to be fish and 4 out of every 17 are going to be crabs. Well, now I have this complete information, and I don't really need crabs because they're asking me how many were fish. So I can see I have a ratio here and a ratio here. And I can write that over here. 13 over 17 must equal F over 19. When you have a ratio equal to another ratio, you have a proportion. And you can solve those by cross multiplying. So we've got 13 times 19 is equal to 17 times F. I just realized when I drew my circle here, I covered up the 1. That should not be 19. That should be 119. Sorry for that error. Let me be a little more careful. We want to make sure our numbers are correct. So when you do this multiplication, 13 times 119, I got 1,547. And that's equal to 17F. Now, we're multiplying the F by 17, so we need to divide it to get the F by itself. And to balance the equation, we'll go over here and divide by 17. When you do that division, you end up with 91. So what does 91 mean in this problem? That's how many fish there were. So there are 91 fish, and that's our answer for this example.